Hello everybody, hope you guys are doing well. So today we will be continuing our journey with in Java, and today we will start with some language fundamentals. Now the Java language, as humans we learn that the subtleties of spoken language through trial and error. We learn where you put the subject in relation to the verb and how to handle things like tangents and plurals. We currently advanced language rules in school, but even the youngest student can ask their teachers intelligible questions. The computer languages have similar features. They are parts of speech that work as composable building blocks. They are a way of declaring facts and asking questions. In this chapter, we'll look at those fundamental programming units in Java. Trial and error remains a great teacher, so we'll look at how to play these units and practice our skills. Now, Java syntax is derived from C. We make comparisons to features of that language, but no prior knowledge of C is necessary. Chapter 5 builds on this chapter by talking about Java's OOP side and completing the discussion of the core language. Chapter 7 is generics and records, features that enhance the way types of Java language work, allowing it to write certain kinds of classes more flexible and safely. After that, we dive into Java APIs and see what we can do with the language. The rest of the book is full with brief examples that are useful variety of areas. If you're left, there will be answer and look at the code. There's always more to learn, of course, we'll try to point out. For others, this is just the beginning of Java programming, and the web will likely be a constant companion. Many sites, Wikipedia articles, blogs, posts, as well as Stack Overflow can help you dig into particular topics and answer small questions that might arise. For example, while this book covers Java language and questions, how to start writing useful programs in Java and its tools. It doesn't cover lower core programming such as algorithms. Programming fundamentals will naturally appear in the discussion and code examples, but you might enjoy applying tangents to help cement certain ideas. If you have, as you mentioned earlier, okay, don't worry. If you are occasionally okay, text encoding. Now, Java is the language for internet. Since individuals users speak and write in many different languages, Java must be able to handle a large number of languages as well as it handles internalization through Unicode character set, a worldwide character that supports the scripts of most languages. Latest version of Java bases its characters and string data on Unicode 14.0, which uses at least 2 bytes to represent each symbol internally. As you recall from the past, Java Oracle endeavors to keep up with Unicodes and standard. Java source code can be written using Unicode and stored in any number of characters. This makes Java a fairly new friendly language. The Java character type and string class natively support Unicode values. Internally, the text is stored either character or byte arrays. However, the Java language and APIs makes this transparent too, and generally you will not have to think about it. Unicode is also very ASCII friendly. The first 250 characters are identical. I was talking about Unicode, so just slash u dash dash dash. Okay, this is this is how the comments. Now you know that how text the programs is stored and can concentrate on what to store. Programmers include comments. So there are two types. One is multi-line. Then we have a single line. It is mostly C style block comments that span multiple lines, limited by star and okay block comments. Now Java doc, the special block contains okay a special block containing slash star star indicates a doc comment. Document is designed to be extracted by atomic documentation generators such as JDK's on Java doc program or contextual tooltips in many IDs. A doc comment is commented by star slash. Just as with a regular block comment, within its block comment line begins with at the rate interpreted by special instructions for document generators and giving it information about the source code by convention. Each line of doc comment begins with a star and is shown. Any leading spaces are ignored. So now using a comment to hide can be safer than simply deleting the code. If you want the code back, you can just comment out the take out the delimiters. The Java doc command line tool creates HTML documentation for classes. Okay, while reading source code and pulling out embedded comments and tags. In this example, the tag creates author version, Class documentation, the tag produces hyperlinks to create class documentation. The comments can appear above classes, methods, and variable definition, but some tags may not be able to may not apply to all of these. For example, at the rate exception tag can be applied to methods. Table 4.1 has all of them. Annotations. The at the rate prefix or another rule in Java can look similar to tags. Java supports the notion of annotation as a Avena marking certain content for special treatment. You apply annotations to code outside of comments. The annotations can provide information useful to the compiler to your IDE. For example, at the rate suppress warnings annotations to hide warnings and potential problems. So let's see something about Javadoc. Javadoc is it's basically it's Javadoc. Um, uh, Javadocs. So what does it do is it's a tool and command for documenting Java code. It generates API documentation from comments in the source code, allowing developers to or from so then if you have any from here from the source code it is generated. How to create Java docs, basic syntax, and include annotations. So all the annotations also will include. So this is generated automatically from the source code. So for example, if you have a code and you have certain comments, then Java docs will do the it kind of gives a brief information about our document summary. Now to create a documentation, you need to do this. Generating how much a code as Java docs, you can generate API documentation using Java doc tool. It can be so the documentation is generated by command. That's what it's trying to say. Navigate to your project directory and use the following command. Command Java docs Java docs. Most IDs like IntelliJ IDE or Eclipse IDE support Java docs and allow you to generate them automatically. Java docs is a tool that generates API documentation from comments in the source code. And so now basically this initial thing, this is the it's generated from the source code. There are annotations. We'll see what is this. Let's see. So it is okay. Annotations. The other rate prefix. We'll see what annotations are right now. Variables and constants. When adding comments to our code, it's critically to producing readable and maintainable files. Then programming is the art of manipulating that content. It's in just about every language. Such information is stored on variables, constants. For easy use of Java has both variables store information. Okay, now let's see. In this snippet, this is the variable, right? Type is jframe. Okay. Okay. The in the snippet, frame is a variable. We load it up at line 5. So this is 1, 2. This is not line 5, but then it's okay. With a new instance of jframe class, and we got to use that same instance in line. So this is the instance created, and then we are using the same instance to do everything. Okay. In line 7. So in line 7 is this. Now are we using the frame? Where are we using the frame instance? We are creating a new label instance over here, JLabel, and then oh yeah, we are adding over here. So this frame is getting added to this label. We use the variable again to size. So we are going to set the size, set visible. Okay, the line 6 contains a constant JLabel.center. What is this? JLabel. Oh yeah, this one. He's talking about this. Now this is a constant. Constants contain specific values that never change throughout our programming. So information does not change may seem like a strange thing. Why just not use it? Constants are simpler to use than data. Math.py is probably easier to remember than 3 point. Okay. So he's saying that variables are basically what we are going to assign values, and then we can reuse them, and constants are something that is going to remain fixed throughout our code. Okay. Okay, now, and since you get to select the name of the constants in your okay, we can create our own constants. Jable it might still, but center gives at least what's happening. Name constants also allows for simpler changes down the road if your code something like the maximum number of some resource we use. Altering that limit is much easier. If you all have to do is change the initial value given to the constant. If you use a literal number like 5, every time your code needs to check the maximum, and you will have to hunt down through your Java files to track down every occurrence of 5 and change it as well. That particular 5 was in fact referring to the resource limit. And that time a manual search and replace is prone to error quite above and beyond being tedious. We'll see more details on the types and initial values of variables and constants in the next section. As always, feel free to use JShell and explore and cover some of those details on our own due to the interpreter limitations. You cannot declare your own top level constants in JShell. You can still use constants defined for classes like okay. Now try typing the following constants in JShell. So these are readily available constants. Do I have to import any? Oh no, these are already present. No need to. This let's. So this is. So I'm going to do math. This is some. I'm doing math dot. Yeah. So this is. So. I don't know because let's see. So this is this is directly running, right? I have compiled this all this test classes here, right? So that's I don't doubt. So I'm directly doing the interpretation, right? And ID automatically compiles the .java. So ID does it in background. There's no not mandated to just run it. So even ID it's doing that thing, but no dot class file is that dot class file has to be generated, right? That is oh, so now in Java 9 there is some features that were added. So you can see from .java without generating and .class. So Java command can compile and run a Java directly in one step without incoming. Okay, I'm using which I'm Java 21. This is It's 23. Yeah. The Java runtime environment is some 23.0, and then so I have inbuilt servers Java hotspot, which is 23.0.1. So when it was installed is 24/10/15. So was this released on that day? 24/10/15. Okay. Now if I try assigning values to it, I'll get an error. So I say math not pi equal to 3. This will not work. It says yeah, this is it's working, but it's doing some starting input or something. Basically, you cannot reassign them. For example, if you're doing this right, creating our own constants. We haven't created our own. We are using all the inbuilt ones. Okay, no types. The types of a programming language indicate how data elements, the variables and constants are we just touched on, are associated with storage in memory. A statically typed language such as C and C++, data type of is simple, unchanging, interval that often corresponds directly to some underlying hardware phenomenon such as a register or a pointer value. In a dynamically typed language, such as variables can be designed arbitrarily, which can effectively change the type throughout the lifetime. A considerable amount of overhead goes into highlighting what's happens in the languages at runtime. Scripting languages such as provide strictly simplified type systems in which only certain elements can be stored. Java combines many of the best features of both statically and dynamically. As in statically, every variable in Java programming element is a type that is known as compile time, so the run system does not have to check the validity of assignments. Unlike traditional C++, Java also maintains runtime information about objects and allows the system to be truly dynamic behavior. So Java code may load new types at runtime and use them in fully OOP ways, allowing casting, polymorphism. Okay, now data types fall into two. So one are primitives, simple that built-in functionality. The others are the reference types or class types include OOP, objects and arrays. Reference types because they refer to larger data. As we'll explain shortly, generics are reference types that refine our existing type. For example, Java has a list class that can store a series of items. In generics, you can create a list string. Because a list can only contain strings, or we could create a list. We'll see that later on. The primitives, numbers, characters, booleans are fundamental in Java, unlike other. They are not objects. For those situations where it's desirable to treat a primitive as an object, Java project will see what's wrapper classes. The major advantage of treating primitive values is that the Java compiler can and runtime can more readily optimize the implementation. Primitive values and competence can be mapped down to hardware. They always have been in lower languages. An important feature of Java is that these primitives are precisely defined. For example, you never have to worry about the size of an int on a particular platform. It's 32-bit signed number. Size of a numeric time determines how big a value can store. For example, a byte is 8-bit signed from -20 to 127. After aforementioned, int type can handle most numeric needs, roughly storing between 2 billion. Okay, now type boolean, true or false. Now remember, these are types, right? These aren't reference types. Like these are primitives. But why all our sizes? Again, it goes back to efficiency and optimization. Okay, now if you are with C background, primitive types look at idealization of C scalar types. This is how they're supposed to look. Java designers made a few things such as supporting 16-bit. But why have sizes at all? Again, this is how efficiency and optimization is. Remember, we need to be optimized, right? The number of goals in a soccer will rarely cross single digits, right? They will fit in a byte variable. The number of fans watching will need something bigger. So depending on our use case, we need to use a specific. Some scientific or cryptographic applications require to store and manipulate very large and value accuracy over performance. If you need bigger numbers and primitive, there is big integer and big decimal in Java.math package. These classes offer near infinite size. Okay. The floating point. Floating point operations in Java follow IEEE standards, 754 standards, which means that the result of the floating point is normally on the same. On different is normally the same. However, Java rules there is for extremely precision platforms that support most applications never notice this. Most application okay. But if you want to ensure that okay, if you then you can use this the keyword strict FP. Let's say variable declaration. You declare variables inside some methods and classes with a type name followed by one or more separated variables name. For example, you can optionally initialize a variable with an expression. Variables that are declared as members of classes are set. Okay, we'll see that in chapter 5. The value for false reference types also gets a default value. Okay. Integer literals can be specified in binary, base 2, base 8, base 10, base 16, binary, octal, hexadecimal. They represent very useful grouping of individual 1, 3, and 4. Binary is denoted by leading characters 0b or 0. Hexadecimal is literals are in types until they are suffixed with an L, denoting that they are to be produced as a long value. With the numeric type, certain numeric comparisons. For example, multiplying a byte by an int, the compiler promotes the byte to an int. Okay, so something. Let's first. Okay, let's int. We were here, right? So every data type will have a value and an integer. Like will have a size mentioned. So let's create a variable. So the way you create a variable is you say what type it is and you mention the name. So it's not necessary to initialize it, although this is how to string interpolation is used. Does it directly take in or who is neither read or written? Let's put something 10. So let's write this as clear and then so this is coming as a text. Okay, so we just need to have this, I guess. Now it's printing 10, and either you can do it this way or you can add two of them on the same line. So this is indicating like both of them are of double type. Then you need to have a, what does it say, remove, and oh, the reason that is something, then you can do the initialization down. So you can say I can declare multiple variables on the same line of the same type. D1 this have it. It's a 10 or 20 something initial start. But we can do, so if you want to do different time, then they have to be a semicolon, right? Or Can we make this allowed? No, it's giving an error. This is not allowed. So what's the problem is that an identifier is expected. So you can say, yeah, we need this token here. So instead of having comma, we separate it this way. This should these are errors, right? So I mean these are not errors. These are so right now it's all right. So, language support for byte at we are in main function. So then we need to declare a bool. These are types, right? These are all. There is when the yeah they'll refer to no copies are passed. Since these are types, so if you I haven't mentioned a name. So if I do jack and then if I come here, I do jack 2 and then I do oh and then bool cannot be resolved to a type. What's happening? Or you cannot. The thing is, this will mention the type, right? What if I want to assign? So this is bool. Bool cannot be resolved. I'm initializing it to true. Oh, there's no type as bool. It's boolean. So you need to be as. Oh yeah, it's saying. Okay, so if I do this, see the error. So it's saying this cannot be a type. I mean because the why it's saying because the primitive types are it's boolean. So you need to make it. Now it will be resolved. Now if I so saying jack 2 is unused, right? What if I try to change jack? Now if I say assign jack 2 as something, make it this as and then lose this out and then print jack. So even though we are this is oh yeah missed that column. So even if this is going to work, but then see, do we have this out anywhere? Let's comment this or get rid of this. So copies are passed here. Let's no not after that. We'll have to do it before. So I have let's do clear. And even if we run this, so oh I did it on the wrong line. So you come here and then just clear this and then so remember even though we have changed jack to false, jack is still true and because these are types, right? What is happening is we are just passing a copy, not the actual value. And there is a certain number. Now it is saying, okay, now this is very striking about type conversions. So, okay, now we haven't come to. It can be so it should result to a value. What he's trying to say. This can be an expression, but it should result to a value. It should get a value. The integer literals can be specified in binary. So there are different ways using which we can specify integer literals. Like this, it can be binary, base 2, x2, opt. Ultimately, see what happens is For example, then you have a binary octal, we have O or 0. Now xi is represented by cross 0 cross found by combination of digits. An hexadecimal is the integer literals are a type of int unless they are suffixed with l, denoting they are to be produced as long value. Okay. Now, the numeric type is used in an expression involving a larger type with a greater range. It can be promoted. So this is type promotion. So type promotion happens when, for example, there's something called as this is suppose if the result is greater than the type range, then we do an upcast. Then we can have a bigger type. This is typecasting. Control S, not F. It's coming outside because it's outside. So if I take it inside the main method, then this one you won't get this. But even if it's outside the class, right? So that is why it's saying that thing. You have it over here. It will work. Anyways, anything written here won't do me any harm. This is outside, right? So there's no need to write. Don't do any harm. Yeah, the type promotion is the result is greater than it's doing compile time, but runtime should work fine, I guess. Okay. So we studied about type promotion. Now when we multiplying by a byte, okay, so he's saying how is the multiplying. So when we do byte by an int, since int is a higher type, okay, so byte will also be promoted because they know multiplication also always will produce a letters. Now you can never go the other way around. For example, smaller to bigger to smaller is not possible. Where did we go? The other way around is going to give me an error. Explicit cast. You can go the other way. This is implicitly the compiler does it for us, so we did not worry about it. Now when we do when you assign a numeric value to a type with a smaller range without an explicit yeah, so if I say this is int, you know what, let's assign this is d1 or d2 is smaller, right? This will need an implicit cast. You have an error already generated there. Implicit incompatible types, possible loss of conversion, because yeah, when you have big to small, there is high possibility that data might be lost. So but we can still do that using explicit cast. This is an explicitly cast byte. Conversions from floating point to the last and maybe least you can add up. So let's do some formatting. Well, let's have this out. Let's have this out. Let's do some. So if I say int Richard. Oh, underscore is also allowed. They can start with a number. The type names, variable names, however you say it. I do 5, 6, 7. This is there in other languages as well. So this is all okay. This is, and then underscore. I have a 0, 5, 1, 5, and then so this is not. So if I sum this, the system dot print, and then if I do the sys out over here of this is, so this is how it's, this is basically indicating a bit good way, so that you know the more better way to this. So this is, it's like unit, tens, 100, and then you have underscore over here. This is 1000, 10,000, right? Then you have an underscore here. Then you have lakhs. So not over here, I guess. I have you, and then now. So this is like a well formatted, right? You can write the number properly, more legible. You cannot start it with an underscore, only thing a floating point. Floating point are basically anything that has with a decimal point, and you can do double, float. Okay. The double also takes in decimal point. Only the difference between float and double is the range. So I'd say float might take 32-bit, double might take, it's all double exactly. Yeah, it's the name is double because it's double of float. And then no, I haven't started with the reference. Where did I go? Okay, yeah. Did it? No, I was in type. Okay. The character literals again. Character A. Cool. Now reference types. Now if an object-oriented program like Java, you create new complex data types, some simple primitives by creating a class. Now each class then serves as a new type in the language. For example, if we create a new class called car, we also implicitly creating a new. Okay, so now whenever we create a new class and we assign a variable to it, like we create the actual instance of that, then we say it is a type of that instance. Classes can have relations with others. They all have, in Java we have parent, like inheritance is there. Okay, now primitives are not in values, right? Copy, that's what I said. However, when we type reference, a reference type is passed. Okay, let's create a class though. This instance is created by us. Now let's create a public class and then create its instance inside. So I say public, I have a class, and then say let's have this as car. So then this might contain some methods and variables. So suppose it contains, not what I'm saying, it has int, it has tires. So I say int tires, and then it has int say number plate, and then it has int, let's change it. Let's have its name. This is going to be the character name, like about type what is the name of the car, and then let's have another thing. What does a car have? Seats. Oh, I can have number of seats. So this is a car, but then what is the problem? Is in its own. Okay, so now this is how Java is evaluating it. But you know what? If I create an instance here, will that work? So I say, now say my car, continue, and then. But now the thing is, it's going to get executed in main, right? So then I have a car type over here. The public type must be defined in its own file. Yeah, should have a file in here is saying and then get it imported, something like that. How to define a class? Let's see, where is you can okay dynamics also. No, let's first create this, right? So I say creating a class in Java. It's public class. Has it to be in the same file, or what if you want to do in the same file? Have I to use it private or something? I'll just remove that identifier public. So I have this class. Now see when I go over here, can't I clear this thing? Forget it. Now when I go is not the variable. No, it's saying this car is a this is a reference type of the type is car. This is what I'm trying to say. The type is car. Okay, now so this is the reference type and this is the instance. We'll see what. We declare a second car type other car and assign it to the same object. Now there are two identical references, my car and another car. Okay, now if I create another, these are both going to, if I say this is my car 2, and then if I assign it so what he's saying is just assign the reference my car over here. So these both are going to refer to the same thing. So if I say this has some values, so if I try to access that, if I do sys out of that variable, then sys out, and I do, if I don't say something like, and even if when I go here and then I do this out, if I do say car dot oh, so this is the reference is my car, right? Sorry, I do my car to dot. So both of them will print the same because your reference has been passed. So see, both are getting 10 then. So if I change it over here, then now both will have 120. The model version of Java initially improved the ability to infer variable types. Starting with Java 10, you can use where keyword in conjunction with declaration and situation and an initiation of a variable and allow compiler to infer the correct type. Okay. Passing references. If I have a function and I want to say how to create a function, if creating in Java, is it function or func? So I have return time, method name, and parameters. So if there is no return type and function, let's have this as method name, no parameters, and then oh no, I'm going to pass this a reference type, right? So when I do method name, just pass in this my this is getting passed. Oh, that is, and now in this I need can be anything, a copy is sent, right? And then why is it giving an error? Illegal stuff. Okay, let's push this out and then have this is that as function definition is something what he's trying to say. Syntax error. Oh, and then return. I'm not returning anything. Record expected. Why is this wrong? I'm not returning anything. What is this? So I have a public. Is the is this wrong? I haven't mentioned. By default it might take something. Student dot. Is it private? Let's see. So this, that's not related to this, but it's something else. We'll see that later on. This method is how I just wanted to show you how to pass a reference type. So anyways, you can arrays in Java. Okay, now what are interfaces? Arrays, these are more complex terms, so A word about strings. Now, strings in Java are objects. They are therefore reference types. So now there's a difference between characters. And strings are different in array in Java. So I say characters to be single characters, but then strings are again reference types. Character is like a single character. When you declare a char, a single thing. When you have, yeah, these are single values, like single. So this will uh, resolve into one single thing, you know. But these are primitives. However, strings, a collection of characters. You can say, uh, but then uh, they are reference types. Expressions produce values. Java evaluates an expression to produce a result. The result then can be used as a part of another expression or in a statement method. Okay. No statements. In any programming languages, the statements. Okay, so the statements perform the real magic. Statements help us in implementing this algorithm. In fact, they don't just help, they are precisely the programming ingredient we use. Statements generally do one of the following for gather input, write output. Now, statements and expressions in Java appear within a code block. Clone mode is basically curly braces and an open and a close. So anything between that will be a statement. Then the conditional. Now another key concept is making a decision if the file exists. Okay, so this is if else. If the condition is true, then go to the statement. Okay. The whole of preceding example is a statement. This is, then you can have if. So see, these are all, so these are anything within a block of code is in statement. That's why yes, statements. Okay. Now switch statements. It's basically like control. So this is an expression. An expression will evaluate to a value, and then this should be a constant expression. Now since there is only single statement, don't need to have those curly braces. Yeah, it's assumed. And is the default mandatory or so this is like, so we have something called as fall through if there is no break. That means if suppose if this matches out, then okay, there is, let's see, in the case is constant integer strings are compared with the string equal, you can specify when execute this, which simply finds the branching and its conditional expression. But not the perhaps you can return to the switch statement then continues and then it's the end of the switch. Or so if this match is made from match till all the down, is it that? So yes. This statements in Java are fall through. Yeah, switch statement in Java fall through by default. You don't explicitly break out. Even if the condition is met, so even if the condition is false, it will still get, because there is a fall through happening over here. That's in Swift. The use case is a bit different. You don't need that break because it's used in the way that switch case in Swift is used to use enum, right? So when we say we are using an enum, we say all the possible values. So now, okay, so we have switch cases in here, and then we have an arrow. Now do while loops. Now the other concept in controlling is a flow, is a repetition. The computers are really good, so I have while condition again. Anything between curly braces is a statement. So unlike loops, we have something called as a do while loop. Do while will, so if you want one iteration to be, then we have the for loop. The syntax is initialization condition incrementer. It's same. No, so you can skip some things he's trying to say. You can initialize. Um, okay, so we will just stop with there and then we'll continue in the next lecture. Just give me 1 minute.